Thank you. I'm really pleased to be here to talk about a project that the Southeast Utah Tamarack Partnership is just beginning to initiate. And that's one that we really realized to do a successful conservation or riparian restoration plan is that a critical first step is to build a conceptual ecological model of how the system functions. And so we're spending the time today to do that right, and we are collaborating with the Bureau of Land Management in Moab, Pat Shaffron's shop in Fort Collins, USGS, the Nature Conservancy, River Red Restoration, and the National Park Service to build this dynamic model that'll go from Westwater Canyon, which is basically the border of Utah, Colorado, through Canyonlands National Park, through Cataract Canyon. And we hope that this model is really going to be the basis for future conservation planning. To date, we've been able to map vegetation communities and analyze the geomorphology. And luckily, I have John to give the big part of this presentation, and he's going to talk further about how we've analyzed and characterized the geomorphology of this river segment. And so I just wanted to give you a little context. Thank you.
Thank you, Sue. I think with the talks that we've had so far today, that one of the points that is perhaps coming through is that when you're dealing with a river system, there's really two major components to that system. Obviously, the river is all about flowing water, but it's also all about flowing sediment, the transportation of sediment from upland areas eventually to the sea. And that, as it appears to be turning out, this latter factor, the movement of sediment down through the riparian corridors, is one of the critical determinants of the composition, indeed even the presence of riparian vegetation. And that, therefore, our idea is to start off focusing on sediment flow as how it relates to these systems. We've already talked about the folks that are interested in this in the Colorado Plateau area. One point that I would like to make right up front is that this is a work zone. It's work in progress. We're just barely starting. As a matter of fact, the whole project's been going now for 1-2 months. And so that all that we've done so far is somewhat tentative. But at the same time, I think we've come up with some rather interesting findings which will have high potential for the future. To start off with, as Sue pointed out, the area of our concern is basically the unrestricted portion of the Colorado River in southeast Utah, from basically Westwater Canyon down to Lake Powell. And what I'd like to do is just take you through a very brief tour of this part of the Colorado River, starting out in lower Cataract Canyon near Big Drops, rapids 1, 2, and 3. Moving on up into Meander Canyon, in an area where the river becomes a bit convoluted. In this particular view right here, you can see about 7 river miles on the river, all in this one little area. Further upstream, a very different situation in Moab Spanish Valley, Matheson Mudlands. Further upstream in Professor Valley, it's different again. And then, not quite to Colorado, but getting close just downstream from Westwater Canyon and the Cisco Landing area. Not to belabor the point, but I think that what you can see from these few examples is that this portion of the Colorado River, where it goes through the plateau region, is a rather complex and a highly variable system. And that therefore it makes a lot of sense to try to put some definition to this variability so that we can anticipate those areas where it will be most important to focus on restoration efforts. We've already gone through this too. Basically, we want to do this, to get to this objective. What we need to do first is to systematically describe the physical components of the system, mainly in its superficial geology and geomorphology. But to focus on identifying those physical features that are most influential on sediment flow. It's been made again and again, but basically the reason for doing this is that the processes of erosion and sedimentation along recurring corridors is probably at least one of the principal determinants of what kind of recurring vegetation you're going to have. To start out, we've gone to basics, and we're using the latest and greatest aerial imagery that we could find to come up with the highest spatial definition of the geomorphology for the region. And to do that, if you look, this little island right here, that's the same island. And this is an example of the kind of imagery that we're using. It's 30 centimeter resolution. Actually, maybe it's more like half a meter, but it's still fairly good. 4 spectral bands. For this particular project, there's 170 image tiles, each about a square mile in size, and this was acquired just a year and a half ago. For those of you that don't have data quite this good, alternative source is the NAIP data sets that have been flown for many of the western states, well, especially Utah, Colorado, New Mexico, and I think recently one for Arizona, which gives you data which, although not perhaps quite as good, is more regional and it's a fairly comparable data set. Moving right along, these are some of the general features that we've been mapping. I won't bother to, you can read the list as well as I can, so I won't bother to go through them specifically. But we're looking at these features plus other more detailed items or components of these features. An example here is one of the image tiles, which is in the Meander Canyon area, about halfway between Moab and Cataract Canyon. And it's a little bit hard to see, but I think you can see here some of the basic features of the system. What we're showing here is an area of fairly stable point bars. And one feature I want to point out is those areas outlined in yellow are areas on those point bars that have been deposited and vegetated within the last 50, 60 years. Piecing these together in larger components first for sub-reaches in the system. Again, here, the area that we just looked at right here. And then moving on out to complete the whole system, this is what we get. You can perhaps study that for just a minute. It might be become fairly apparent that if we just stay with this approach, we're missing quite a bit of the picture. And what we need to do is to fill that picture in with other data set types. Some of these here are the existing geological data, satellite image data, and topographic information. If we then illustrate that in this example here, and by the way, this is the entire reach from the Colorado border down to Lower Cataract Canyon, the upper reaches of Lake Powell. Colored it blue so we can see it a little better. One way we can fill it in is with satellite image data. And this gives you both some idea of the nature of the topography through which the river is flowing, and also some idea of the geology. But especially since this particular image here looks to be a bit blown out, I think we'll continue on and take a look at the geology with a geologic map instead. When we do that, we can see that as we move down through the region, the river crosses, in some cases, the same rock strata. In this case, it's the Glen Canyon group. In other cases, things as different as the Mango Shale here, Cutler Group here, and Montgomery Formation here, and again back into the Cutler Group down here. That the river is flowing through a rather, although the Colorado Plateau geology isn't that complex, still for the case of sediment flow through the system, it is a rather complex region. One of the better things to do, perhaps, is to combine both the geology and the topography with a merging of the satellite data and the geological data, and we can see this situation a little bit better. And then, if we continue the process by looking at the topographic data showing the gradient on the river channel, I think that we can see that as the river flows through different geologic formations, that there is quite an impact on the gradient on the stream, especially through Westwater Canyon here. And as we come down through the system, it's a little hard to pick this up. No, it's not showing up, so I think I'll go on. When you can't see it on an image, let's go to a graph instead. And what we see here is that if you look at the entire reach here, going from River Mile here, by the way, is not where we usually put it, but basically Colorado here down to Cataract Canyon here. You can see the variation in channel gradient, which is, although a little bit stylized here, quite abrupt and highly variable as it changes all the way down through the system. And you can also, we've also placed here the channel width, and you can see, of course, that there's a very nice inverse relationship between river gradient and channel width. It's kind of a no-brainer. If you have a steeper channel, the water's going to flow faster. It doesn't have to be in a channel because it's wide. You carry the same amount of water down through the system. If we, to continue to fill in the picture here, I want to also look at some entirely different dimension, in this case, time, and want to determine how the river channel has been changing through time as far back as we can conveniently do it. And perhaps the best way to do that is take a look at some aerial photography. This example, the Moab Spanish Valley Matheson Wetlands, in a fairly early image that was acquired in 1944. That outlines the active river channel at that time. You see the very, very large active sandbars in the system. Then superimposing that on the 2010 data, you see that there's been quite a bit of change. As a matter of fact, the channel width through the area there has lost almost 40%. And that area then has been vegetated by predominantly tamarisk and willow. Taking a different area here in Professor Valley, about 15, 20 miles upstream. Again, the same time period in the 1944, 2010. You can see perhaps here that there's been much less change to the channel, only about 15 to 17%. In other areas, such as Westwater Canyon or Cataract Canyon, there's been almost no change at all. As a matter of fact, through the area of the loop in Lower Meander Canyon, there's been no change either. Just one final example here, taking you through an area just downstream of the potash facilities on the river, about 20 river miles south of downstream from Moab. Looking at satellite image data in 1987, 1998, and 2009. I think you can see that there's been, I'll repeat that, and 87, 98. Hello. Are you there? I believe we have a failure in our battery pack here. Anyway, that in this particular reach on the river, the change has been much more difficult to capture because it's been a more a continuous change, and a change which has been a combination both of vertical accretion of with the point bar deposits, but at the same time a wholesale shifting of those deposits and indeed the entire river channel through time. Thank you, sir. Your lifesaver. Okay. If we were to then look at the entire river corridor and attempt to plot these variations both in the magnitude and the style of channel change, we come up with something like this along the river system. And all I want to point out here is that where the river goes through different different bedrock down through the system, the style and the magnitude of the channel change or the erosion and deposition of the fluvial sediments changes dramatically from reach to reach. Perhaps better see that again on a graph where the limits of the reaches are shown with fairly light pink lines. And you can see that the changes in the average reduction in the river channel all the way down the system, and then plotted up here at the top a preliminary indication of the style of change along each one of the reaches. So, what have we gotten to so far? Well, in a preliminary fashion, what we've determined is that as we already knew, the Colorado River corridor through the Colorado Plateau is a highly variable, highly complex system. If we want to understand that system in any kind of detail, we have to break it into smaller pieces that are more similar, more contiguous. And in this particular case, there's at least 10, perhaps as many as 12 or 15 different discrete reaches down the river, which have very different characteristics geologically and also in terms of sediment movement through the system. And of course, this is what is strongly influencing the distribution of riparian vegetation. And then finally, the one thing that we're beginning to get out of this preliminary look at the system is that those areas that are particularly sensitive are those areas where the surface deposits, the sediment deposits in the river system are the most susceptible to erosion and then subsequent redeposition. And these are characterized by areas where there's been a lot of historic channel change, very low gradient systems, less than a tenth of 1%, or translate that in perhaps more meaningful terms, about 1 foot per mile. And in areas where the channels, the immediate channel margins and the channel banks are unconstrained or just partly constrained, and areas that are close to local sediment-laden tributaries, so that the deposits that we're dealing with here are usually relatively fine-grained, sandy materials, and that in all these cases the deposition has been in the last 2/3 of a century. So although, don't I wish that this was the end of it, it's not just the very beginning, but do want to point out that I think that even with a relatively limited amount of work in this area, that we've already come up with some indications of where we're going to be headed in the future. And I think certainly the major of those is that we have to concentrate on the linkages between the physical environment and how that impacts sediment flow through the system, and then perhaps more importantly, how those variations in sediment flow influence the riparian vegetation in the region. Thank you very much.